Okay, so we're given a cubic polynomial, so ax cubed plus bx squared plus cx plus d, and so we know this has roots alpha, beta, gamma, and we want to find the sum of the roots 1 over alpha, the sum of 1 over alpha plus 1 over beta plus 1 over gamma, and this is going to lead into what we're doing later, but we'll just do this as a standalone example for now. Combining these fractions, this is equal to beta gamma plus alpha gamma plus beta alpha, alpha beta gamma. And the reason we've written in this form is because now this is in a form that allows us to use our results for the relationship between roots of a cubic and the coefficients of the cubic to write this in terms of the coefficients here. So this is equal to, this is the sum of the products of two roots, and that's equal to c over a, so this is equal to c over a divided by the product of all of the roots, which is minus d over a, so that's multiplied by minus a over d. These cancel each other out, we get this is equal to minus c over d. Okay, so that's the first example. Now we're going to draw a line under that and move on to another example. So we have a specific cubic polynomial here, which is x cubed minus 3x squared plus 3x minus 1, and so this has roots again alpha, beta, gamma, and we want to find a new polynomial that has roots 1 over alpha, 1 over beta, and 1 over gamma. This is often a question you get asked, but the combination of roots might be different. It might say find a polynomial with roots 2 alpha, 2 beta, 2 gamma. But what I'm going to show you here for this specific example is still the general method. We want to use what we know to find the combination for our rules of relationships between roots and coefficients with the new roots. So for example, now we've got new roots 1 over alpha, 1 over beta, 1 over gamma. We need to find, to know the coefficients, we need the sum of the roots. So the sum of the roots is 1 over alpha plus 1 over beta plus 1 over gamma, and from what we've shown just above, that's equal to minus c over d, but in this case c is equal to 3 and d is equal to minus 1, so this is just equal to 3. So the sum of the roots is 3, and well, that's equal to the new coefficient. So our new polynomial has a1 x cubed plus b1 x squared plus c1 x plus d1. So this is the sum of our new roots, so this therefore must be equal to minus b1 over a1. Now if we take the sum of the pairs as such, this is equal to 1 over a times 1 over alpha times 1 over beta plus 1 over beta times 1 over gamma plus 1 over alpha times 1 over alpha, but combined in such a way. And then again, combining the fractions in a similar way as we did before gives us that this is equal to alpha plus beta plus gamma over alpha, beta, gamma, and this is equal to turns out it's minus b over a times minus a over d, which is equal to b over d, which is minus 3 over minus 1, so that's 3. And because this is the sum of the pairs, this is equal for us in our new coefficients to c1 over a1. And note the aim here is to find coefficients a1, b1, c1 and d1 that satisfy all these equations. And note this is not a unique solution, because if we think about this polynomial here, it has roots, but if we multiply these, every single one by 2, the roots are still the same, because the roots are when the polynomial is equal to 0. So multiplying by a constant multiple does not change the values that give us 0. Okay, and then finally we've got 1 over alpha times 1 over beta times 1 over gamma, but that's just 1 over alpha beta gamma. That is equal to minus a over d, which is just minus 1, minus a over d, sorry, a over d is just minus 1, so this is just 1, and this is equal to minus d1 over a1. And it turns out this is a very trivial example. I mean, we can see from inspection, well, first I'll give the answer from this method. It turns out that just putting in exactly the same coefficients solves this. If we just take our new polynomial, can be x cubed minus 3x squared plus 3x minus 1. These coefficients satisfy these equations, and this is because the roots of this equation are always 1, so flipping them upside down we get the same roots, we can get the same equation, or any multiple of this, so we could also get minus x cubed plus 3x squared minus 3x plus 1. Okay, but the point is that I want you to take from this video is this stuff here, and that is just trying to be flexible and being able to use what you already know about the combination of roots, whatever your new roots are, and then trying to write the sums of your new roots, the sums of pairs of your new roots, and the sums of triples, or in other words the product of all the roots for cubics or quartics. We can go up to quartics in terms of previous results that you already know. So you see this we write in as a fraction where we knew what both the numerator and denominator were in terms of the coefficients, and we did the same for the other three. So you can do this with any linear transformation that you'll be expected to do for further maths. That's all we're going to cover on this video, and in fact all we're going to cover for roots of polynomials. Next video we'll move on to series for further maths. I hope to see you then. If you've got any questions, let me know in the comments. If you did enjoy the video, please like and subscribe, and I hope to see you in the next one.